All right. This is a very nice question. This is fun. Honestly, this is a very easy question, but it is so damn good. It is from 2012 gate. It was apparently worth 2 marks, by the way, but that is extremely crazy. Because you'll see how kind of garbage this question is, but it's a very good question because it's so good, it's so fundamental. Let's go over it. So they've said an internet service provider ISP has the following chunk of CIDR based IP addresses available with it. So it has this particular address 245.248.128.0/20. Okay, so the subnet mask is /20. The ISP wants to give half of this chunk of addresses to organization A, so half to A and a quarter to B, while retaining the remaining with itself. Which of the following is a valid allocation of addresses to A and B? I think you can actually solve this question in 5 seconds because of how kind of silly it is. But you know what, I'm actually going to take this as an invitation to go and have like a world tour around the question and then come back to answer it, because it covers so many nice concepts and it's a very good revision question as well. So notice how the sort of subnet thing is /20. Now I think we all know. So if we go for IPv4 wait, hold on. So if you just go with IP addresses, I don't need to mention IPv4 or whatever. So IP addresses will be 32-bit in length, and and basically the way these addresses are written is written in dotted decimal or the octet form. Now if I take the octet form, the way it is written is you have 8 not dot 8, but the point is that you have 8 bits here, 8 bits, 8 bits, 8 bits, right? That is what is happening, right? Now /20, if you look at it, is basically a collection of 8 plus 8 plus how much would that be? 4, right? So that means eliminate 8. Look at this third octet. Okay, the third octet has 8 bits, of course, right? That's why it's an octet. And if you expand it, right, let's expand it. So 8 plus 8 is 16, so we'll start from 17, 18, 19, 20, 21, 22, 23, 24. Trust me, this is a very fun question, by the way. Like, it really teaches you quite a lot. So 4 bits, right? So we'll remove 4 bits from here, right? We are left with 4 bits, right? Now the way this works is, and I think like there's some magic number or whatever nonsense, I don't know the exact terminology, but the point is you ignore this other 8 octet that you have, you forget about it. The point is that whatever number of bits that you have left in the octet where the subnetting kind of ended, right? So whatever the remaining number of bits that you have, if you take it and sort of raise 2 to the power of that particular number of octets, so not octets, sorry, number of bits. So here it is 4 bits, right? 4 bits. So that is 16. So that means the block size, the total block size that we actually have available is actually 16. Now what does that block size even mean? So notice how the address they had given was 245.248. So the address they have given is 245.248.128.0, right? That is what they have given. What that means is, again, of course, you have to be a sensible person and understand that this, of course, does not go up to infinity, and the ISP does not have 255.255.255.255. Of course not. That is one of the most stupidest things to assume, but of course it makes sense, because generally if you don't know the concept well enough, it makes a lot of sense, right? Even it made sense to me back when I did not really know it, right? And I was getting confused. So how do you actually find out what the bound of the ISP address actually is? It's very simple. Take this third octet, because that is where we found out the split. Take the third octet, so it is 128, add a 16 to it. What is a 16 added to a 128? So you'll get a 4-1, so you'll get a 4 here as well, and that becomes a 144. Okay, so the actual ending address is 245.248 and not 144, 143.255. Right? So this is how it is. So this is the full ISP thing that it has. Now these are all the addresses it has. That is it. There is no more than this. No more, no less. This is the exact number of addresses that it actually has. And what it wants to do now, again, the question what it is saying is, if this is the total pool of addresses that it has, it wants to give half of it to A, and then it wants to make a quarter chunk here and give this to B, and this much it wants to keep to itself, the other quarter that is left. This is what is supposed to happen. Okay, This is what is supposed to happen. Okay, now we'll keep this in mind. Okay, I'll keep this. I mean drawing a box probably is a wrong move, but yeah, this is what the ISP owns. Okay, I just want to highlight that fact. Okay, now let us consider how much A can actually own. Now A wants to own half of the whatever the ISP has, right? Now think about it. So we started the /20, right? /20, which means that we have 20 bits for the network, and you have, how much would it be? 12 bits for the host. Okay, now basically what that means is, now these 20 bits are reserved for the ISP, right? That is what that means, that the ISP was given these 20 bits, and whatever, through that only it is basically able to give you these kind of addresses that we already talked about, this 128.0 to 143.225, sorry, 255. Now what you have to understand, and what we all have to understand here, is that the host addresses that we have, these 12 bits that are remaining, this is the stuff that has to be divided now, right? That makes sense, because these network ID is fixed, like we can't do shit on that, like we can't change it. Okay, but we can only do further division, addition, multiplication, whatever nonsense it is, we can only do it on the host bits. Okay, so you have 12 bits. So of course, if we have 12 bits, what does that mean? We have a total of 2 power 12 addresses. That is what that means, right? And we are supposed to give half of that to company A. That means that the company A will get 2 power 11 addresses, right? That makes sense. Now what does that mean in terms of IP? So the 32 bits will be divided as follows: 21 bits for the network, and then 11 bits for the host. This is the crucial idea. Okay, now we won't stop here though, now I will however point out that for A, the proper subnet that is required is /21. We can also push this further. In fact, why not? We can go for B as well. Now again, we'll start with 2 power 12. So we'll have 2 power 12 addresses, but again the point is that organization B wants a quarter. A quarter is a not a 2 power 4, whoops, that is wrong. It is a 2 power 2. Okay, 2 power 2, and when we do that, we get a 2 power 10. What that means is that if you make a 32-bit division for organization B, right, 22 bits will be for the network, and then 10 bits will be for the host. This is what is happening, which implies that B will be using a /22 subnet, right? Where is this 2122 coming from? The network ID, right? The network is using 21 bits, 22 bits, and so on and so forth. Even that's basically how it works. But I won't stop here. Let's have a bit more fun. So notice how for network A we said it is 21 bits /21, right? That is the subnet. Now let's play with that idea for a bit. Okay, let's play with that idea. I want to copy a couple of things for just a second. So let me take this particular ISP nonsense that I had written. We'll take this with us. We'll carry this with us because it's a very nice little fun fact that we'll paste here on the corner. Okay, it's a very fun thing. Trust me, this is very fun. It's so amazing. I mean, I never loved networks this much because I honestly never really put much time into it, but this is cool. Okay, so /21, right? Okay, again, so 32 bits, again, as I said, 8 bits, 8 bits, 8 bits, 8 bits. The first two are already gone, so right, that accounts for 16 bits. Now how many bits? 21 minus 16 is how many bits? 5 bits. So if you take the 8 bits, right, again I'll do the same nonsense: 17, 18, 19, 20, 21, 22, 23, 24. 5 bits out of these are reserved now, right? So these guys are gone. You are left with 3 bits. Now what did I say last time? So the total block that you actually have is 2 power 3 because there are 3 bits left now, right? So that is 8. Now what does this mean? Now what that means that again the address was 258.248.128.0. Now we have to ask ourselves, okay, so the ISP actually owns this much. Okay, the ISP owns this much. Now how will it look if I do the blocks of 8? Again, remember, the ISP owns all of this, right? We are just trying to see how the division of 8 actually will sort of split the whole address space up. Okay, so 128 plus 8 is how much? So you add a 16, you get a 136. Okay, so we'll add 245.248.135.255, of course. But notice, is 135.255 actually the last address? I will go up here. No, it is not. 143 is the last address. So we'll keep pushing. We'll see how it kind of looks. Then 135 plus 8. How does that actually look? Or it will actually be 136, not 138. 8 plus 6 is a 14. That is a 4. That is a 1. So 144. Right? We are getting there. So 245.248.136.0. 245.248.143.255. Observe, right? This is what I want us to observe, right? Notice the fun stuff that is happening here. So the ISP owns a block of 16, right? It owns a block of 16 which looks like this. But when we perform the division according to A's requirement, which is basically splitting it into 2, you will notice how the addresses basically start and end. 128, 135 is one block, 136 and 148 is one block. Keep that in mind. That is very amazing. That is very important. Okay, let us now move and we'll do the same division for B as well. The reason why I'm being so pedantic and kind of long-winded about this, because we could have ended this like maybe a million years ago. I didn't have to expand and explain this so much, but it's so fun, trust me. Now again, 22 bits is the subnet. I don't have to write the whole bit expression thing again, I guess, but again, just for the sake of not brevity, but whatever it is, 16 bits consumed already. Now we have 8 bits here, right? So 22 minus 16 is how much? I think it is a, what is it, a 6? Yes, it is a 6. So now if we actually were to go ahead, right, we would realize that we have 1 2 3 4 1 2 3 4 8 bits. 6 of them are consumed by the network ID. 1 2 3 4 5 6. All of these are gone. We only have 2 bits left, which means the block size is 2 par 2, which is equal to 4. Okay, which is equal to 4. Now again, I will once again paste the the ISP block thing here for reference. Short, reduce the size a bit, and boom. Okay, now play with me here. Okay, so let us start. So 245, let me not write it at the edge, right? 245.248.128.0. now it has to go up in size of 4. So 245.248.128 plus 4 is how much? It is 132, but we write 131.255, right? Again, remember the reason that is because we count from 0, we don't count from 1, right? That is how binary stuff works. So we again have, whoops, let me write it properly actually. 245.248.132.0. now if we add 4, how much does that become? Go on then, perform the addition. 136, right? But we write 135.255. Amazing. Are we there yet? No. 135, 143. So we have to drag this out up until 143. So we keep going. 245.248.130. What will this be now? It has to start from 136, right? And it has to end at 140. 248.139.255, and that is one block, right? And then finally 245.248.140.0, 245.248.143.255, and boom. Would you look at that? No, don't scroll. Boom. This is the /22 network, or the /22 subnetting of the /20 original thing that we had, right? This is kind of what C wants. Notice the beauty here. So after performing the division, in the 4 blocks, basically according to the /22 division on the /20 network, these are the address ranges that you're getting. Okay, these are the address ranges that we're getting, and these are the only valid address ranges. Okay, if you perform a /22 division, and again, these are the only address ranges that are valid if you perform a /21 division. But of course, now that this is where you can kind of play it smart, and you can play a bit cleverly, I think. Where let me try to actually write this out properly, because this will look cool if I am able to actually get it right. So this is what is happening. So the ISP has this much, these many addresses, right? And what the /21 thing is doing, what the /21 thing is doing, the /21 address, come on, give me that, thank you very much. Let me scroll. Yes, there we go. So the /21 thing is doing this, right? It is expanding the ISP size. It is not expanding, sorry, no, it is not expanding, it is just dividing it into these blocks. These blocks still fit into this original 16 original 16 block size. They are 8 in, this is now 8 in size. And now if we go to this massive monstrosity that we have now, which is this nonsense, this thing that we just got, come on, reduce the size. Yes, now that is kind of what I was going for. Kind of close enough, right? So the point here is, now look at this, right? This is what the 4 block size looks like. So again, all of these addresses still are within this address. I hope I make that clear. Now notice, for example, that if I give the /21, if I give company A this particular block, if I give the company A this particular block, which is the 245248128 245248135 that means that in blocks of 4 in the /22 addressing, I am giving them basically the first 2 blocks, right? That is what that means, right? Notice, right? Can you see the beauty here? It's so amazing. You can very easily see the structure and how exactly the division is happening. If I give company A this particular block, which is the 245248136 245248143 if I give them that is the last 2 blocks that you have in the /22 range. And then the first 22, or sorry, the first 2 blocks that you have, you can give one of them to the company B and you can keep the other one for yourself. I hope I'm making my point very clear, because now what I'm going to do is I think I can just copy paste this entire thing and we can take this with ourselves to the actual question thing that we had, because then look at how easy answering it is. You don't need this much work to actually answer it, by the way. You of course don't have to do this much stupidity. Not stupidity, well, I mean, we did quite a lot of work to have kind of a lot of fun. Oops, hold on, let me yeah, there we go. That's how it is done. Okay, I guess that thing just works pretty well. Anyways, okay, let me paste that thing here and let me reduce its size as well so that we can refer to it, right, a bit more maybe. There we go. Now that looks good. Okay, all right, now look at how fun this question now is, right? So now they're asking, yes, organization A has to get half of the address and organization B must get a quarter. So which of the following is the valid allocation of address A and B? Right, now notice, so A has to get a /21 address, as we have already observed, and B has to get a /22 address. So based on that, you can see that first option, okay, 21 22 21 22, but the next 2 options are 22 21 24 21. C and D are completely garbage. They're completely stupid. In fact, here you can also apply a little bit of your maybe -5% of your brain, and you can look at option B and go, it is saying, and this is incredible what it is claiming, that you will take 245248128 and you will give that to company A, and you will also take 245248128.0/22 and give it to company B. How the hell is that possible? How can you give the same range to 2 different companies? That does not make any sense. So by elimination, of course, you can easily come here. You don't even have to do all of this, but the splitting is very nice because you can sort of see how this exact answer comes in, because of course you can rely on the examiner giving you stupid options like this where you don't even have to use your brain. But in options where the thing is very close, where you have 136.0 and 128.0 and you have to decide how the splitting actually happens, this kind of operation is how it happens actually. Okay, so let us look at it now. So they are saying that can the company A get 136.0? Is that possible? Well, let us look at our division that we have done. So if you look at the second block that we made here, right, which has these two blocks, right? You will notice that the second block is 245, 248, 1360, 245, 248, 143, 255. Of course, company B can get the second division. Why the hell not? It can get it. 100% it can, right? But then now, of course, the second question is what blocks should the company B get, right? So it will be either of the first two blocks in the fourth, four block thing, right? /22. So you'll see that here they're claiming 245, 248, 128.0. We'll verify if that is valid or not. So, and you will very clearly notice that yes, this range is in fact valid, right? We can in fact give this to C because it is 245, 248, 128.0 and 245, 248, 131.255. Of course, this is valid. Therefore, you can give this entire range to company C. You can give the second half range of 245, 248, 136.0, 245, 248, 143, 255 to company A, and you can take this range for yourself, ISP, which is 245, 248, 132.0, 245, 248, 135.255. The ISP can have that. See how amazing and beautiful that is, right? So if you look at the original 16 chunk that we had, right, where we had 245, 248, 128.0, 245, 248, 143, 255, in that the first it is not very fair to kind of use this, but you can kind of see how the division actually occurred, right? And it all makes sense, I believe. So yeah, that's basically it. Now this question was basically trash because there was not a lot to do here. You could just figure out the subnetting bits and then look at the numbers, and you could just eliminate the options, and that was way faster than whatever we did here. But of course, it explains so many things about what has actually happened and how the bit division and stuff actually occurs, and I think it just was much more valuable. That's about it. See ya.